Okay, eighth grade. So our learning target today is I can identify the number of solutions to a linear system by graphing and solving. You have three choices in today's work. We'll of course talk about those choices, but your answer is going to be that there's one solution, no solutions, or an infinite number of solutions. So those are the three possible things that can happen. Solutions really are answers. So we want to know how many answers or how many times there's an intersection. Do they intersect one time, no times, or an infinite number of times? That's what we're really asking. How many times do they hit each other? So for the first two equations, we have to set the equations in order of y equals mx plus b. Equation number 1 here is already set as y equals mx plus b. So equation number 1 is y equals 2x plus 5. So we have that y equals mx plus b already locked in. Equation number 2, though, has some work to do. So we have this equation of 3x plus y equals 10. It's in ax plus by equals c form. So we're going to have to rewrite this equation and solve it for y. So I'm going to show my work down here in this space. We have 3x plus y equals 10. Solving, I'm going to subtract 3x, copy and paste. And as we work, we go y equals 10 minus 3x. So I solved that for y. I got rid of the 3x, copy and paste. If I haven't used it, drag it down. Y is alone. If I haven't used it, drag it down. If I haven't used it, drag it down. So there's my y equals mx plus b. Notice it's out of order a little bit. Using the commutative property, we could flip those two things around. So I'm going to take this answer here, and I'm going to put it in as my equation number 2. So equation number 2 then is rewritten in the form of y equals mx plus b. So we have y equals negative 3x plus 10. So it's this equation, same equation, but I just solved it for y. So those are my two equations now. I'm going to erase all of my work here, just so that it doesn't look as messy on my screen, but you probably will need that still in that space. Okay, so those are my two new equations, y1 and y2. We want to know what is true about those equations. How many times do those two lines hit? Do they hit once? Do they hit, they don't hit at all, which means they're parallel, or do they hit everywhere, which means it's the same line? We're going to work through that right now in our work. So how can you tell? Well, we can fast graph this. So we're going to start with the 5 as our y-intercept, and we'll run our slope from there. So our blue line has a y-intercept. Here's my y-axis up at 0, 1, 2, 3, 4, 5. Here's my y-intercept of 5. And my slope here is 2, which really is like 2 over 1. Rise 2, run 1. So from there, we're going to rise 2, run 1, rise 2, run 1, and so on. Rise 2, run 1. All right. Well, the other equation here, my slope is, or my y-intercept is 10. So I'm going to go up to 10. 5, 6, 7, 8, 9, 10. Here's my y-intercept. And my slope is negative 3, which really means negative 3 over 1. So down 3, right 1. Rise and run. So we're going to go down. 1, 2, 3, right 1. It hits right here. Down. 1, 2, 3, right 1. I'm having a hard time seeing my board here, guys, because of the lights in my room. So bear with me on my data points. Okay, so let's keep going here. So I need to put this out of the way. Our two lines, and we have a blue line that's increasing, and we have a red line that's decreasing. My two equations, clearly they do have a point of intersection. They hit at, we would say, 1, 7. Their POI is at 1, 7. That's the POI. So how many times do these two lines hit? They hit once. It's called solution. Solution means just hit. It has one solution. And how can we tell in the graph how many times they hit? You look for an intersection. Do the lines intersect? All right. So when we graph it, it's really easy to see how many solutions it has. You just look to see how many times it intersects. But the question really is, in the rest of our work for today, is how can you tell in the equation? So I'm going to erase all this stuff to kind of clean up my mess here, and we can take a look specifically at these equations. Looking at these equations right here, how would I know if they intersect? Well, you look at two things. You look at their slope. If it's the same slope, you're parallel. That means they're growing at the same rate. They don't have the same slope, so we'd say our slope is different. So they're not parallel. So they should hit for sure. You look at their y-intercepts too, and the y-intercepts kind of help us tell. But how can we tell without a graph? We look to make sure that they have different slopes. So go ahead and write those notes there. We're just looking to see if the slopes are different. Looking at our slopes here, we have a slope of -3 and 2, different slopes. They should hit somewhere. Might not hit in the graph space that we can see, but they're going to hit somewhere, and we can find that by doing what we did yesterday. So answer is one solution. And remember, solution just means intersection. All right, hang in there, guys. You'll do pretty well in this lesson today, I think. Just looking to see how many solutions or how many intersections we have for each of these graphs. All right, let's look at the next example then. If I'm going too fast, go ahead and pause that video. Otherwise, we're going to move on. We want to know how many solutions for these two equations. Neither one of these are solved for y, so we have some work to do. I'm going to show my work down in the space below here. So I'm going to rewrite this first equation here. I'm going to show my work down. 3 minus 3y equals x. I'm going to go ahead and erase mine when I'm done. You guys don't really have the opportunity to do that, so any sort of white space you can find, I would show your work. I stop, chop, chop. I say no. Solving for the variable y. Of course, we want to solve for y, so I'm going to put my hand over all of that. I'm going to get rid of the 3 by subtracting 3, copy, paste. And then if I haven't used it, drag it down, because that's 0. If I haven't used it, drag it down as -3y. And on the right-hand side, I have x minus 3. I say no, and I chop. My job is to get the variable y alone. It's not alone right now. It's multiplied by -3, so we're going to divide by -3, copy, paste, paste, paste. We do have a lonely variable there, so I'm going to throw a 1 in. So my job was to solve for y. Let's see if I managed to do that. So as I solve, I end up getting a y equals, this is a -1/3, because I'm going to pull the negative to the top, and I'm going to separate the fraction in the variable. And at the very end, I have -3 divided by 3. This is a triangle problem at the end here, which is +1. There's my equation, y equals -1/3 x plus 1. I've taken this equation, I've rewritten it. Y equals. Now I'm out of space, so I'm gonna erase mine. You don't have the opportunity probably to do that on your paper. So just go find some white space somewhere. I'm gonna do the same thing for the second equation. If I'm going too fast, go ahead and pause the video. Remember, we're just solving for y. It's all hand method here. Here's the second equation. We're solving for the variable y, so we're gonna solve for this. So I'm gonna subtract x, copy, paste. If I haven't used it, drag it down. And on the right-hand side, we have -6 minus x. I said no, and I'm going to stop, chop, chop, recognizing that there is a -1 here. There's a lonely variable. My job is to solve for the variable y. Right now, y is not alone. There's a 3 attached to it. To get rid of that, we divide by 3, copy, paste. We're going to paste, paste in this problem. Working left to right then, we have y equals, there's -2 coming out of here. That's a triangle problem. Plus, and I'm going to separate the fraction and the variable in this problem. We get -1/3 reattached to the variable x. So we have y equals mx plus b here. It is out of order a little bit, so when I go to write it in, I'm going to rearrange some things. Y equals -1/3 x plus -2. So there's my graph there. I'm going to erase all of my work down here just to kind of clean up the space because it looks so messy, but you probably will just leave it right in there. Okay. So as I start to graph these then, I'm going to fast graph these. I'm going to start with a y-intercept of 1, and I'm going to work from there. So my y-intercept of 1 is right here. And then I'm going to work my slope. My slope is -1/3, which means I go down 1, right 3. Down 1, right 1, 2, 3. I'm having a hard time reading the graph here. Down 1, right 1, 2, 3. And there is my line. You can maybe do it one more time, down 1, right 1, 2, 3, just to kind of give me a picture of my line. So I'm going to connect those dots with the line tool. All right. And I'm going to compare that to the bottom line. The bottom line I'll do in green, so it has, this is a 3. I don't know if you can read that. My y-intercept here is -2, so -2. There's my y-intercept, and my slope is -1/3, which means down 1, right 3. So we're going to go down 1, right 1, 2, 3. Down 1, right 1, 2, 3, down 1, right, 1, 2, 3. As you notice, these two lines are parallel. Hopefully some of you recognize that right from the beginning, that they were going to be parallel lines because they had the same slope. They have the exact same slope. That means they're growing at the same rate. They should be parallel. So, how many solutions? No solutions, because remember, the word solution means how many times does it intersect? How many times are two lines going to intersect if they have the same slope or the same growth? They won't intersect, so none, no solutions is your answer to that question. How can you tell looking at the graph when two lines have no solutions or they never intersect? They're parallel. If you know that they have no solutions, looking at the graph, you would say, well, they're parallel because they're never hitting or intersecting each other. Parallel lines have no solutions. Well, how would you tell without looking at the graph? Their slopes are the same. Their slopes are exactly the same, but what is important that you understand is that their y-intercepts are different. So their slopes are the same. So up here, both of their slopes were negative 1/3. So if I go ahead and back and look at this, then both my slopes are negative 1/3. Same slope, so for sure parallel. But are they the exact same line? No, because the y-intercepts were different. Otherwise, they'd be the exact same line. Same slope, same y-intercept, it's the same line, which is what we're going to talk about next. So the answer to this question is that we have no solution because they never hit each other. Parallel lines have the same slope and they never hit each other. All right, on the top of the next page then, page 5, this will be our last question for today. So we have these two equations. They have to be solved for y. First equation's ready to go. It's already solved for y. The second equation requires us to do some work. So down here we have 3y plus 6x equals 3. We are going to solve for the variable y. So we're going to subtract 6x, copy, paste. As I start to solve then, if I haven't used it, drag it down. If I haven't used it, drag it down. If I haven't used it, drag it down. I'm going to stop, chop, chop here. And I'm going to solve for y. We're going to divide by 3, copy, paste. Paste, paste. We get y equals, as I work from left to right then, we have 3 divided by 3, which gives us 1. And we have negative 6 divided by 3, so I'm going to go ahead and just divide that out. It's a triangle. Problem is negative 2. I'm going to reattach the variable. So I do have my y equals mx plus b here. Using the commutative property, I'm going to flip these two things around. So we have y equals negative 2x plus 1. So that equation, after I solved it for y, becomes y equals negative 2x plus 1. Now I'm going to erase all of this just because it's so sloppy on my board. And that cleans things up a little bit. So now when I go to graph these two equations, I start as a fast graph. I go ahead and plot that y-intercept of 1. So here's my y-axis. The y-intercept of 1 would be here. And I'm going to work my slope from there. This is a slope of negative 2, which really means negative 2 over 1. So down 2, right 1. So from my y-intercept, I go down 2, right 1, down 2, right 1, down 2, right 1. So there's that first line I graphed. All right, now I'm going to graph the second line. The second line, I start at positive 1. Oops, same point. My slope is negative 2, which means negative 2 over 1. It means I go down 2, right 1. So I go down 2, right 1, down 2. Wait a minute. Right 1, down 2, right 1. They are the exact same line. How could that be? So as I look at the equations, my equations are y equals 2x plus 1. The y-intercepts are exactly the same, and the slopes are exactly the same. Yeah, they are the exact same line. So the question is how many solutions, which means how many times do they intersect? How many times do these two lines intersect? Everywhere. Those two lines intersect everywhere. So we would say that they're in infinite solutions. And if you want to go ahead and use this symbol, you can. As infinite solution because they intersect every single spot they intersect. Those two equations do. So how can you tell on the graph? You can tell on the graph by just looking to see if it looks like just one line. If you look at my graph right now, it looks like I only plotted one line. But I really did plot both. I plotted both of those equations. So you'll only see one line when it's infinite. And how can you tell without the graph? It's when you have the same slope and the same y-intercept. Same slope, same y-intercept, same line. There's your notes there. Same slope, same y-intercept, same line. So this one has infinite solutions because they hit everywhere. Same exact line. All right. So that's our work for today on number of solutions. For our summary, go ahead and go to the summary. You have one solution, no solution, and an infinite number of solutions. So for talking first about one solution, first of all, you have to be in y equals mx plus b form. Make sure you solve for y, otherwise this does not work. If you have one solution, that means that you intersect one time. It intersects one time. So you would just draw a picture of two lines intersecting one time. Maybe this line, that line, they intersect right here. They have a POI. That's an example of one solution. No solution. No solution means the two lines are parallel to each other. They never intersect. Infinite number of solutions. So you have a line, and then you graph another line, and they look like one line. So it's the same line. So to summarize what we see, if there's one solution, they have different slopes, and they have different y-intercepts. Well, they don't necessarily have to have different y-intercepts. Let me take that back. They do have to have different slopes, though. If they have different slopes, they're going to hit somewhere. No solution would be when they have the same slope. Same slope, that means they're growing at the same rate. Y-intercepts could be different, or would be different, I should say. An infinite would be the exact same slope and the exact same y-intercept. Infinite means it's the same line. Okay, so that's kind of our summary for today's work. Your job is to finish the bottom on page 5, all of page 6, and then do the remembering on page 7. That's your homework for tonight. Have a fabulous night, 8th grade.